Good morning. We are now discussing few concepts of astrophysics, under which we study the classification of stars. The first classification is the Pickering classification or the Harvard classification of stars. The Harvard group of astrophysicists under the guidance of E.C. Pickering classified the spectra of 400,000 stars, and this sequence can be written as OBAFGKM, among which the hottest stars belong to O group, whereas the coldest stars belong to M group. Now let us study this sequence of stars one by one in detail. O group stars are the stars whose spectra consists of lines of singly ionized helium atoms. The temperature of these stars vary from 30,000 Kelvin to 50,000 Kelvin. Next we have B group stars. These are the stars whose temperature varies from 10,000 Kelvin to 30,000 Kelvin, and the spectra of these stars consists of lines of neutral helium atoms. Now we have A group stars. A group stars are the stars which contain or which do not contain the lines of neutral helium atoms, and the temperature varies from 8,000 Kelvin to 10,000 Kelvin, whereas these stars contain the spectra of hydrogen lines. The hydrogen spectra can be observed in A group stars. Similarly, we have F group stars. F group stars, and these are the stars which contain spectral lines of ionized calcium, iron, and titanium at the violet end, and the surface temperature of these stars varies from 6,000 Kelvin to 8,000 Kelvin. Next we have G group stars. G group stars are the stars which consists of closely spaced spectral lines. The spectra of these stars consists of closely spaced spectral lines whose temperature, the surface temperature of these stars varies from 4,500 to 6,000 Kelvin, and Sun is an example of G star. The spectrum of Sun consists of number of closely spaced lines. And next we have K group stars. And these are the stars which consist of closely packed absorption lines of metals as well as other elements. The surface temperature of these stars varies from 3,500 to 4,500 Kelvin. And finally, in this classification, we have M group, which are the stars consisting of the lowest temperature among this classification. The temperature of these stars varies from 2,000 to 3,500 Kelvin, whereas the spectra consists of the band spectra. These M group stars exhibit the band spectra. This is about the Harvard classification of stars. Now coming to the Archives luminosity classification, and this classification is based on the luminosity of the stars. The previous that is Harvard classification was based on the temperature of the surface temperature as well as the spectra of the stars, and here it is based on the luminosity. Again, the stars are classified into 7 groups. The first group of stars are called the supergiants. And supergiants are extremely massive compared to all other stars, and they are highly luminous. Hence, these stars are said to be at the end of their lifespan. They are near to their death. And these stars are further classified into 1A and 1B. 1A stars are more luminous than 1B. Examples of supergiants are Betelgeuse and Antares. The second classification of stars is bright giants. These are the stars whose luminosity is 1,000 times the luminosity of the sun. Example for bright giants are Adara and Sargeras. The third classification is normal giants. And these are the stars whose luminosity is 100 times the luminosity of the sun. And the example for normal giants are Arcturus and Aldebaran. Coming to the next classification, that is subgiants. The luminosity of subgiants is larger than that of the sun and lesser than that of the previous one, that is normal giants. Example for subgiants are Acrax and Mia Placidus. The next classification is dwarfs or otherwise main sequence stars. These are the stars whose mass and luminosity is comparable with that of the sun. Mass and luminosity are near to that of the sun. Example are Sirius, Alpha Centauri, Vega, etc. And the final 6th and 7th group stars are the subdwarfs and white dwarfs. Subdwarfs belong to 6th group, white dwarfs belong to 7th group of stars. Thank you.